Okay, so the first topic for today has to do with testing status reports, and this is a topic I started to talk about last time. I had noted that information on test success and test coverage was useful for two different purposes. One was sort of operational issues. So in other words, fixing out what bugs need to be fixed, for example, what tests still need to be written, and that sort of stuff. But it can also be used for decision making. And at the end of class, last time I had left you with a slide, which we'll get to in just a few minutes, asking about a situation to reason through the implications of some statistics on the one hand for reasoning about what it implies about the number of known bugs at any one time. So here I mentioned briefly last time a set of metrics that are good candidates for reporting all through the development process, but particularly through the testing phase. So the number of system trouble incidents, the number of active system trouble incidents. Could anyone here remind me of the difference between merely a system trouble incident, we called it last time, I think, a defect or defect report, versus an active STI? What distinguishes the active ones? Through what process have they gone through? Okay, a ticket has been created by them. So this would be a system trouble incident, has been ticketed. A ticket has been created for it. For the most part, we use that term for mean reported system trouble incidents. But what further things have to be done for it to be considered an active STI? Sanitized. Okay, they need to have been sanitized. So they need to have been passed over to count what sort of information, what happens during sanitization, what sort of things are weeded out or included following sanitization. Anyone? What is the purpose of sanitization? Okay, duplicates is a big part of that. Is this bug, is this reported STI merely a duplicate of the number? If so, we don't want to assign it a whole nother, as if it's a separate system trouble incident. Among other things, if it's resolved for one, it's resolved for the others. And so we'd like to fold it into the same one. We may take the description of what steps would be needed to reproduce it and include it in the description of the original one. That would be useful. But we don't create a whole other STI, so we weed that out. What other things do we weed out in sanitization? Yeah. Good. So give an example of another thing besides a duplicate that would be considered sort of illegitimate.
Like if there was bug reports about a feature, like something that was considered a bug by a user, but is actually working.
Yeah, it's actually working properly. It's working according to specification. Yeah. Just the user misunderstood how it was to work. So that would be a good example. Another one would be a bug report that's so incomplete as to be useless. You know, it has no information. The name is not readily understood. Anyone else? What other sorts of bugs might be viewed as illegitimate? Outdated, yeah. So they relate to, they were fixed in the past, either working outdated set of the code. Working with an outdated set of the code is not itself means for dismissal, but if this is something that was fixed in a previous version, they just didn't have that previous version, there's no use creating a whole other STI for it. Okay. So active STIs, and breaking them down by severity and priority. Distinguish for me severity versus priority. What does severity mean? Yeah.
How basically how broken project will become if it's not
Okay, so you want to refine that a little bit? Kevin?
Yeah, I think you covered it correctly.
Oh, okay, so it's how bad is it is it if this bug does materialize. If this bug comes about, well, how disastrous are the consequences, right? It could be a crash, it could be data loss, or it could be an aesthetic, sort of just how it appears that's unpleasant. And those are different levels of severity, the worst of them being data loss, corruption of documents. So severity captures, if it materializes, how bad is it? What is priority capture in addition to that? It takes into account severity, but it also takes into account what? Well, that could be factored in there. Could be factored in. Often that's not factored into priority, and that's instead folded into the triage process. It may be a higher priority, but you decide this is not worth fixing, and it's not captured in the priority score. But a team could decide to capture that priority. But what other critical piece of information besides severity? Frequency of occurrence. What's the likelihood this will really bite a user? Right? And I talked about other things. Percent of tests that complete, percent of test steps that are completing, what fraction of those tests actually are successful, actually pass. So not only do the tests complete, but they either pass or fail. What fraction of them pass? So I might write here, you know, percent passing. So it's not only making it through there, it's passing. If it's not even making it through, you're still in the dark about whether it's going to pass or not through the test, because the test is just not working properly. You can't. It's not a proper tool for ascertaining. And I mentioned some other ones that are you know, sometimes a little bit harder to collect, but interesting. Fault feedback ratio. How many errors are introduced per fix done? That requires longer-term collection. These last two, number of defects open and defects closed, I want you to collect information on those in the first two at least, okay? So you might have something like this. This is a test status report that might occur in a project. So you have a feature, a certain number of tests that work against it. What number of those tests are reaching completion in terms of how they run? What number of those, what number are successful, and what's the fraction that are successful, that pass? What fraction of those tests actually yield favorable outcomes rather than detecting a problem? This can give you some sense about where we're at in the project. And you look at the bottom line here, summarizing across all these different features, and you start to see, okay, you know, we're doing pretty well. We've got 91% of the tests passing. So here we have this bugs found, bugs fixed diagram, which relates to exactly this. Defects opened versus defects closed. We could have substituted those names. Defects open, defects closed. So let me ask this. Early on, what do you generally expect will exceed what? Which of those do you think will be larger early on? Bugs found. Later on, we're hoping that it's reversed, right? That we're fixing more rapidly than we're finding. And so it's not uncommon that you'll see a diagram kind of like this. And you can go find in the literature examples of these sort of diagrams for actual projects. Bugs found versus bugs fixed. And they're a bit more noisy than this diagram would suggest. But often they include this sort of general pattern of having a situation where the two lines meet. Now these are rates of bugs fixing, the number of new bugs found in a given week, the number of bugs fixed in a given week. So let me ask this, when do we have a maximum number of bugs? At what point is the total number of bugs that we have at its maximum, given in mind that bugs found means bugs found per week and bugs fixed is bugs fixed per week? When is the total number of bugs that are remaining to be dealt with at its maximum? Yes? Okay, good. Yeah, so it's right at this this point here when the lines intersect. And give me the reasoning for that. And actually, it's the same number in this next point here where they're also identical. Give me the basic reasoning for this. What's going on in this phase here at an intuitive level? Why do you say it's maximum here? That's correct. So
Yeah.
what is it that's going on here?
Well, the number of bugs found is decreasing, the number of bugs fixed is increasing, or at least not decreasing at the rate the bugs found are. So at the point where the bugs fixed exceeds the number of bugs found per week, then the total number of bugs starts to grow.
Okay, yeah, so all through this time, because it is true that this is decreasing, this is increasing, but the operative thing here, the most important thing here, and I expect you to understand this for pop quizzes or exams, is that the number of bugs found per week exceeds the number of bugs fixed per week. So you've got more coming in that are going out. The rate of them coming in is greater than the rate going out. It's like you have water pouring into your bathtub faster than it's raining. The bathtub's going to rise, coming in faster than it's raining out. Here we have bugs found per week that are exceeding bugs fixed per week. The number of bugs you're going to be keeping track of total is just going to be increasing all through this time. You have more and more bugs all through this time until they meet here, in which case, what happens during this period? Here, the number of bugs fixed and bugs found is the same. Same thing in the next week. So what's going on with those 2 weeks? Well, there's no change in the total number of bugs to be fixed. Some number are getting fixed, equal number are being found. It's going to be no change. I found 3 and I fixed 3. Same total number that I still have to deal with on either of these weeks. What's going on to the right of that? Anyone? What's going on over here?
Fixing more than
Yeah,
finding.
you're fixing them at a faster rate than you're finding them. So over time, like now your drain is going faster than the water's coming in. Over time, the water's going to be draining down. Bugs are going to be draining down. So what you're going to see from this is a situation, something like a rising curve, plateaus in the middle, and then a dropping curve for the total number of bugs. So this is time on the x-axis, and this on the y-axis is total number of STIs or defects, in other words. Okay? Total number of defects. It rises, plateaus, and declines. This is a very common thing for projects. And knowing where you are on this curve is helpful to understand kind of the likelihood that the project will converge in time, say, for the next milestone. Where are we at? Here we may be dealing with a timeline of 2 to 3 weeks. Where are we at in terms of this this plateauing? Are we still at the phase where we're finding a lot more bugs than we're fixing them? In the phase where it's plateaued out, or are we at the phase where we're cleaning up? We're mopping things up. We're fixing bugs a lot faster than we're finding them. In other words, where are we at? This diagram and this diagram implies the one on the board, which shows this kind of upside down U shape. Does that make sense? Are people comfortable with that? So what's shown in the diagram on the slide implies the diagram in the board. It's the integral of the difference between these two lines. You subtract bugs found from, and you subtract from that bugs fixed, and you already integrate that up, sum it up over time. This is what you get, the thing on the board. It's the integral of the difference between those two curves. Okay? Does that make sense? Okay. Now, there's a process called directed triage, which is used consciously by the project manager together with the triage lead, and often with the council of following, and later they bring in the dev lead or test lead. They go through a process called directed triage. Now this process involves deliberately wading through the reported STIs to prioritize them. In the sanitization process, we're often going through prioritizing as part of sanitization. And then in the triage process, we may fill in any missing information for sanitization, and we're going to decide, are we going to fix this bug or not? Does it become an important bug, or is it merely an active bug? Okay, or does it get thrown? Does the STI get thrown out altogether? Okay. So the issue here is that you may have a lot of STIs in your database, your issue tracking system like Jira or Track, that you don't know yet how serious they are because no one's sanitized them yet. No one's attached priorities to them yet. No one's even figured out if they're duplicates. And if we want to know how close we are to actually pulling together this version that we're trying to get to the client next week, or if you want to know what's the chance you're going to actually get the features done in time for the next milestone in this class, it makes sense to pause sometime and just wade through that and figure out where are we at. How bad is this? We have 50 bugs, 50 defects reported, 50 STIs reported, system trouble incidents reported. Are these likely big problem? Maybe they all boil down to 10. Just a very common one gets repeated over and over and over and over again. Reported over and over and over and over again without really being as big a problem. So maybe it really boils down to 10 truly active bugs there. And we want to prioritize them to indicate, okay, what level of priority and severity these have, and figure out which things we want to actually fix. So directed triage is a deliberate process undertaken to reduce uncertainty in a queue work. You're saying, okay, where are we at? We want to know how bad the situation is or how good the situation is. Let's wade through these things and assess them. Does that make sense as a process? Okay, good. Thank you. Good. So directed triage is something that I would hope you're going to occasionally do with your projects. Maybe it doesn't require anything more than a group discussion because the number of bugs are all in people's heads, or the bugs are all in people's heads. But I'm hoping that if you folks are using Jira and Track well in this class, you'll actually have a set of bugs you can wade through like this, and then you figure out, okay, are we in pretty good shape? Do we have all level 3 issues, sort of low priority issues, and we're in pretty good shape, or are we dealing with situations where we have 10 level 1 issues, high priority issues that require fixing, in which case we've got a lot of work to do just to fix those bugs, and we should hold off on any of these new features. The client would be better off with us just fixing the bugs as they are rather than adding new features. You might even want to do this if you don't have time before the end of a milestone. You do it before the beginning or at the beginning of the next milestone. Where are we at? Do we really have the luxury of implementing several features, or do we just need to clean house and fix these bugs? If a team last year had done that, the client would have been far less disappointed. Okay? Okay, so those are some comments on defect reports, and I'm going to